Hello, my name is Nohai, and this is Physics 2211 Lab for Oscillations. The purpose of this lab is to analyze the motion of a spring mass system where the mass swings in an arc while oscillates on the spring, and use tracker and glow script to compare the difference. For fundamental principles, we need Newton's second law, which is F net equals change in the momentum over delta t, and for this lab, specifically F net equals to the spring force plus the gravitational force. And we have energy principle, which is delta E equals the work of the surrounding plus Q. And for this lab, our system will be mass, spring, and earth, which will give us the equation of delta K plus delta US plus delta UG equals 0. And lastly, we have update formulas, which is pretty handy to use. So for the velocity update formula, we have VF equals VI plus acceleration times delta t. And we have position update formula, which is RF equals RI plus V average times delta t. Okay, for tracker, we have our system. Like I said, it's just mass, spring, and earth. There's no surroundings. The mass of the object was 0.402 kilograms. The initial position was for x negative 0.116, for y negative 0.634 meters, and the initial velocity was 0 meter per second, and the time elapsed was 9.497 seconds. So we got glow script codes. The initial conditions were basically the same thing as tracker. And then we got constants, which is G is just 9.8. Spring constant is 6.83. Relaxed length of the spring is 0.123. And then the next lines are just how to find L, L hat, and S. S is just the length of the spring minus the relaxed length of the spring. And then lastly, we have equations to find kinetic energy, gravitational potential energy, spring potential energy, and lastly, total energy. So finally, we have energy changes. These are the lines of codes to calculate it. Our time elapsed is 9.497. We have to define initial energies to find the change in the energies. We have to find the gravitational force, spring force, and net force, and also utilize the update formulas we talked about in the fundamental principles to find ball velocity and ball position. And then we also have to update the spring constantly. And then lastly, we can calculate energy changes with the variables we defined. And our purpose is to find delta E. So at last we calculate that. It's just E minus E initial. It could be also written as delta K plus delta UG plus delta US, just to let you know. So as a result, we've got two models that are very similar looking but slightly different, and this is because of the external forces such as air resistance or human errors. For possible sources of errors, there may have been calibration error when using tracker, low precision in locating the position of the mass in tracker, and lastly, drag force not being included in the computational model. So what does it mean? Is the energy principle satisfied? Yes, delta E stays at 0 over the given time interval, which means the energy is neither created nor destroyed. For the estimated oscillation period, by the X position, I got 1.614 seconds. By Y position, I got 1.519 seconds. There's an offset of 0.095 seconds, which is because the movement of the object in the X direction and Y direction is different. In conclusion, we were able to prove the energy principle. Last but not least, the two models were not exactly identical to each other due to differences in external forces. Alright, that's it for today, and thank you for listening.